Hey everyone, welcome back. Ready to dive into some more fascinating AI stuff with us?
Always ready.
This time we're looking at large language models, and to guide us, we've got a lecture from Christopher Manning.
Yeah, Manning. He's a Stanford professor, right? I think I've seen his name on some papers.
Exactly. He's been right there watching AI evolve from the beginning. So
Sure.
he's got a lot of interesting insights about how LLMs work, what they're capable of, and why it's so important for, well, everyone to understand this stuff.
Yeah, it feels like AI was this kind of niche topic for years, and then boom, ChatGPT hits the scene, and suddenly it's all anyone can talk about.
Right. It totally captured the world's
Yeah.
imagination. What was it about ChatGPT that really stood out to you when it first appeared?
Well, I think what surprised a lot of people, even the experts like Manning, was just how capable it was.
Like, in what way?
I mean, just imagine asking it to write a sonnet about Wikipedia where every single line has to start with the letter W.
Okay, now that's a pretty specific and kind of weird request.
Right. But ChatGPT just nails it, like in seconds. The fact that it could understand the prompt, the sonnet structure, the rhyming scheme, A&D weave in facts about Wikipedia was just mind-blowing.
So how did these LLMs learn to do all that? It seems like magic, but Manning says the learning process is actually surprisingly straightforward.
Yeah, he actually compares it to a giant game of Mad Libs, you know?
Mad libs,
Yeah.
like the word game.
Yeah, exactly.
Yeah.
Basically, LLMs are trained on these massive amounts of text data, and they learn by predicting what the next word in a sequence should be.
So like the cat sat on the Olon, and the LLM has to figure out the best word to fill the blank.
Exactly. And it does this over and over and over again with billions of words. And in the process, it starts to pick up on language grammar relationships between words and concepts. It's pretty wild.
So something so seemingly simple can lead to such complex results. It's amazing. Manning also talks about how LLMs have gone through these distinct eras of development.
Yeah, he starts with this era of basically just building bigger and bigger models, feeding them more data, throwing more computing power at them. It was kind of brute force, but it led to some real progress.
And then things shifted to focusing on training LLMs to actually follow instructions and answer questions directly.
Right, which is how we got ChatGPT. But now Manning says we're entering a third era that's even more incredible, the era of thinking LLMs.
Thinking LLMs. Okay, now you have to explain this one.
So the key is this thing called test time scaling, where these LLMs actually generate a lot of text themselves as a way of reasoning through a problem before they give you an answer. And Manning uses this great example where he asks an early LLM to solve a simple math problem.
I'm going to guess it didn't go so well at first.
You got, at first, the LLM just spits out some random number. But here's the interesting part. Manning adds, let's work step by step to the prompt.
And just adding that phrase changed how the LLM approached the problem.
Totally. Suddenly, the LLM starts trying to solve the problem, systematically writing out its thought process step by step. It still made some funny math errors along the way, like its own version of math, but eventually it actually got to the right answer.
Wow, so it needed that prompt to kind of activate its thinking mode. That's fascinating,
Mhm.
but how do the more advanced LLMs like GPT-4 handle that same problem?
They solve it perfectly, no problem. The progress in LLM development is incredible. And to really show the potential of these thinking LLMs, Manning highlights this fascinating example from DeepSeas, which is a Chinese AI company that's really pushing the boundary.
I've heard of DeepSeas. What kind of example are we talking about?
So he presents their R1 model with this tricky problem. Find two 3-digit palindromic numbers that sum to a 4-digit palindromic number.
Okay, hold on. I have to think about that one for a second. Palindromic numbers are the ones that read the same backward and forward.
Mm.
How does the AI even begin to approach that?
What's really cool is that the DeepSeas R1 model actually enters what it calls think mode. It then generates thousands of words of text as it reasons through the problem.
So it's not just crunching numbers. It's actually trying to understand the concept of palindromes
Yeah,
and how to combine them to meet the criteria.
you got it. And what's even more amazing is that it makes mistakes. It corrects itself and it keeps going until it finds the right answer. It's like watching a human solve a puzzle.
That's incredible. So we're seeing these LLMs move beyond just generating text.
Yeah.
They're actually reasoning and problem solving. It's like a whole different kind of intelligence.
It's definitely a shift in how we think about AI, for sure. But it turns out the principles behind LLM development aren't just limited to language. Manning points out that they're also driving progress in other areas of generative AI, like image generation.
Oh, right. Like all those AI image generators that have exploded recently, Midjourney, Dandy, all of them creating these incredibly realistic images from just text prompts feels like magic.
And here's a cool little detail. The foundational idea behind these image generators, something called diffusion models, actually came out of research at Stanford years before these commercial applications even existed. They work by imagining taking a photo and slowly adding noise until it's just a blur. And then diffusion models run that process in reverse learning to remove the noise and reconstruct the original image.
So research that might have seemed obscure back then is having this huge impact now. It really shows how important academic research is for driving these kinds of innovations.
Absolutely. But before we get too carried away with all the amazing stuff, it's important to remember that LLMs aren't perfect. Manning cautions us about assuming they understand everything perfectly. He actually shared some of his research on LLMs being used to provide legal advice, and the results were kind of concerning.
Oh no, did the LLMs start making up their own legal precedents?
Not quite, but they showed this surprisingly poor understanding of actual legal documents. They were misinterpreting key points and even contradicting well-established case law. It's a good reminder that we can't blindly trust these LLMs, especially when the stakes are high.
So yeah, while we can marvel at what they can do, we also need to approach them with a healthy dose of skepticism. They're still tools, and like any tool, they can be misused or applied incorrectly.
Exactly. Which leads to another point Manning brings up, which is this kind of concerning trend where U.S. AI companies are becoming increasingly secretive about their models and data.
It's kind of ironic, right? We have this incredible potential for AI to advance knowledge and solve complex problems, but there's this growing culture of secrecy that could actually hold things back.
That's what Manning argues, and it's interesting because in contrast, you have companies like DeepSeek in China who are taking a much more open approach, publishing detailed technical reports, sharing insights into their engineering processes.
So researchers might actually learn more about cutting-edge LLM engineering from looking at what Chinese companies are doing.
It's kind of a weird situation, right? And Manning is a big advocate for open science and university research. He believes that collaboration and sharing knowledge is absolutely crucial for driving innovation and making sure AI benefits everyone, not just a select few.
It's a good reminder that breakthroughs often come from unexpected places, and that working together is often more effective than going it alone.
Totally. Now, before we move on to part two, I think we have to address the big question that's on everyone's mind. What does the rise of LLMs mean for the future of work?
Yeah, are the robots coming for our jobs? That's what everyone wants to know.
Well, it's not quite that simple, but LLMs are powerful tools, no doubt about it. And they definitely have the potential to automate a lot of tasks that currently require human intelligence.
Like writing reports, summarizing documents, translating languages. The possibilities seem endless.
And it's not just white-collar jobs that could be affected. We're already seeing AI being used in manufacturing, logistics, even healthcare.
So it's safe to say that the job market is going to look very different in the years to come. But how does Manning view the role of LLMs in the workforce?
He emphasizes that LLMs are tools, and like any tool, they can be used for good or for bad. The key is to view them as partners, not replacements.
Partners that can help us do our jobs better and more efficiently?
Exactly. They can augment our capabilities, free us up from those tedious, repetitive tasks so we can focus on more creative, more strategic work.
So it's about learning to collaborate with these technologies to leverage their strengths while also understanding their limitations.
Precisely.
Wow.
But we also have to be aware of the potential downsides, things like job displacement and widening socioeconomic inequalities. We need to start having these open and honest conversations about how to make sure the benefits of AI are shared equitably so everyone has access to opportunities in this new tech-driven world.
It's a conversation that needs to start happening now, not later.
Absolutely. We need to be proactive in shaping the future of AI, making sure it's developed and used in a way that aligns with our values and benefits all of humanity.
Well said. This has been a fascinating look at where we are with LLMs and where things might be headed. But I know we've only scratched the surface.
Yeah, there's so much more to explore.
In part two, we're going to delve into some of the ethical considerations surrounding AI, the potential dangers of misuse, and the whole debate about the nature of intelligence itself.
It's going to get deep.
I can't wait. Stay tuned, everyone.
You know, it's interesting how this whole LLM thing is playing out on a global scale.
What do you mean?
Well, like Manning talks about how there's this kind of paradox happening right now in the AI world. On one hand, you have these major U.S. AI companies becoming super secretive guarding their models and data like it's some kind of top secret military project.
Yeah, it's all about protecting their algorithms and maintaining that competitive edge, right?
Exactly. But Manning actually argues that this whole trend toward closed AI development could end up hurting the U.S. in the long run.
So by being too protective, they might actually be losing their advantage.
That's what he suggests. And then on the other hand, you have companies like DeepSeas over in China taking a much more open approach. They're publishing detailed technical reports, sharing insights into their engineering processes pretty freely.
So researchers might actually be able to learn more about cutting-edge LLM engineering by looking at the work coming out of Chinese companies.
It's kind of ironic, isn't it? And Manning is a big proponent of open science and university research. He really believes that collaboration and knowledge sharing are essential for driving innovation and making sure AI benefits everyone, not just a select few.
It's a good reminder that big breakthroughs often come from unexpected places, and that sometimes working together can lead to much faster progress than trying to do everything in isolation.